Welcome back. Today's video is going to continue our conversation on transformations, but today we're going to talk about the reflection of the flip. Another way we talk about a reflection is to think about looking in a mirror. So when you look in a mirror, your points are opposite of each other. The mirror is actually the line of reflection. Or we could also think about it like a butterfly. In a butterfly, the line of reflection is the body, and then the wings mirror each other. Or you can think about it like symmetry. So here, the reflection or the flip. Graph the image of our point M, which is -4, -3, which we see is right here already on our graph. And it says reflect over the x-axis. Now that's important. Over the x-axis. We have to know where our line of reflection is. And let's just go ahead and label that. This is our line of reflection. So what happens on one side needs to be mirrored to the other. So here's M. From my line of reflection, I see that M is 1, 2, 3 units away, which means M is going to go to the other side. It's going to go across the line of reflection the exact same distance, with equidistance, 1, 2, 3. So this would be my new M. Remember, our new coordinates use the little apostrophe, meaning prime. So my pre-image and my new image, and I've reflected it over the x-axis, or the line of reflection. Every coordinate has to be equidistant from that line of reflection. So here we have the point S, and it's at 3, 1. It's already on here for us. It's reflected over the y-axis. So my line of reflection this time is this y-axis. Now they're going to tell you that. They won't always be highlighted, so you have to be careful, but my line of reflection here is the y, meaning what's on one side is going to flip over and look exactly the same or mirror to the other side. So if I look here, I went 1, 2, 3. I'm 3 units away on one side, so I'm going to be 3 units away on the other. That's what a reflection does. I'm going to label it, it's the same coordinate, but it's prime. It's after I've moved it. So pre-image, image, exact same distance away from the line of reflection. So up next, we're actually going to graph an entire figure. Here I have, looks like a rectangle, and I need to graph the image of the rectangle, TUVW, after a reflection over the y-axis. So as you can see, they've already highlighted the y for me, but this here is my line of reflection, meaning everything on one side needs to flip to the other side. Now we're going to go ahead and flip one at a time. So if I look here, if I think about it, my V is 2 to the left, so V is now 2 to the right. And then we have U. U is 2 to the left here at 4, so U would be 2 to the right here. So my new U would be here. Now, T, well, T off this symmetry is over, that's at -9, so that T is now going to be at +9. And the W was at negative, so it's moving to the positive. So again, we're reflecting however far away one point is to one side, it needs to flip to the other. It's not going to slide, it's going to actually flip over. And when you do this, you will have a nice straight little rectangle. So what's up next? Up next, it says write the coordinates of the vertices after the reflection over the y-axis. All right, so let's flip it over, and then we can tell the new coordinates. So I'm looking here. Here's my line of reflection again, right? They said the y-axis, and it's actually been highlighted. So here's my line of reflection, which means everything on what's on the left now needs to flip over and will move to the right, equidistant from this line. So what's really cool here is if you notice, L is on the actual line of reflection. That's fine. That just means that my new L will also be on the line of reflection because it's not away from it. It's 0 away, so it's still 0 away here. It hasn't moved. So my L is the same, so I'm just going to rewrite that. That's not going to change. Now my K looks like it's 1, 2, 3, 4 to the left, which means the new K, the pre-K is here, the new K is going to be 1, 2, 3, 4 to the left here, and I'm going to call that K prime. Now M is off of the L here. M is over, if we count over, that's 8 to the left. That means M needs to go 8 to the right. And we're just flipping it over. We're using a mirror or a butterfly. So M prime is over here. And we could draw the little triangle. Your computer will actually draw that for you. And now we're going to label them here. So K, my new K, where is my new K? Well, it's 1, 2, 3, 4, 1, 2. So it's over 4, and my Y value is 2. And the M now has an X value of 8, and my Y value looks like, let's be careful here, that looks like -7. So count carefully when you're trying to determine your X and Y's. We just have one more today. Again, the coordinates of the vertices after reflection over the x-axis. Okay. Ooh, they did not tell me by giving me a highlighted line where the reflection was. Now it tells me over here the x-axis. So I have to think in my brain, I'm like, okay, so I'm going to flip over this line of reflection right here. This is my line of reflection. So everything has to be opposite. So I'm going to move away or over. I'm going to flip over. So K here is 2 below, which means K would be 2 above. I just moved it over. That's my new K, and I put K prime. So I didn't change my X, I just changed my Y. So I'm still at -8 on the X, but my Y is now +2. Okay. Look at L. L dropped down 2. So L is going to go up 2. So instead of being 0, -2, I'm now at 0, +2. And my M is over here at -9, -10. Think about that. That's just going to be the opposite. I'm going to flip it up here. It's going to stay -9, right? Because I'm going straight up. I'm flipping it over. So it's still going to be at -9. And it was at -10. So now it's going to be +10. So I'm moving it to the other side, equidistant. So instead of -10, I'm going to put +10. So this is -9, +10. So we're just taking everything and flipping them. However it's asking me, be careful when it asks you for the line of reflection. If it doesn't show it to you, you're going to have to think, oh, which way am I going? Remember, all points are equidistant. We're taking it, we're just flipping it over. So if we drew this, it would look like the exact same shape. It's not changed size. It's not changed any angles. Everything's the same. We just sort of took the line of symmetry or the line of reflection and we flipped it over. So if we thought about this as a butterfly, if we folded it on the line of symmetry, all of our points would line up. They would be the exact same. So flip or reflection is where we go across and flip it over.